Okay, welcome to chapter 43 in the practices book. This is all about data storage, page 759. And so, just to start off, it used to be that buying disk storage was horribly expensive. And therefore, they went to great lengths to make sure that you didn't, fill up your hard drive. Now that's just not the case. It's dirt cheap. Basically, the cost it takes to manage storage is often higher than buying storage. Yes. And so they make a distinction in the book between having storage and managing storage. Yeah, okay, good stuff in there. You need to read that. Okay, so some of this stuff is going to be repeats because we have two different textbooks, and so it's just kind of strange that we have a lot of repeats. But so I am going to go through this one at a little faster clip than normal because you've seen an awful lot of this stuff before. Okay, terminology on page 760. So we have traditional hard drives, the spinners, so to speak, one with moving parts, right? Okay. They got spindle, they got platter, they got heads, things that move. A solid state disk with no moving parts. Very, very low or practically none latency. If I'm reading a file and I need to stop and go over here and get this file over here, it's just instantly, the seek time. And originally, when they were first came out, they were designed to emulate a standard hard drive, a SATA connector on the end. That way, you could just pull out a physical spinner and plug in a physical, solid state disk, and the machine wouldn't even know the difference. That's not the case now because the storage technology is so different. SATA was designed for these, I'm going to go ahead and say these slow devices, and so even though the latest and greatest SATA standard can't keep up with the direct attached NVMe solid state disks. So you can, if you wanted, find a SATA version of an SSD, but I wouldn't recommend it. Okay, the drive controllers. So we got the SATA, SCSI, and SAS. And SAS is basically just serial attached SCSI. It's just longer cables, okay? It's SCSI, but I need the cables to be a little bit longer. And SCSI had a limit on the number of devices you could have on a single ribbon cable back in the parallel SCSI days. And so this just kind of made that go away. You could have okay. The host bus adapter. Typically now we're talking about something on the motherboard, right? Some sort of a controller on the motherboard that handles these things. So I might ask you, where is the disk controller in an NVMe drive? One that looks like a little stick of gum. Where is the disk controller? It's actually on the drive itself. It's on the device itself. In other words, the host bus adapter just sees this thing as a PCIe device, and the device has to have its own guts that says, oh, by the way, I'm a storage device, and I'm a disk controller, and here's my disk, and here's So they're kind of sort of complicated. Okay, we talked about how the M.2 is actually a mechanical and electrical form factor, but it does not dictate what kind of interface. You could get an M.2 SCSI or an M.2 NVMe, right? Because it's just a mechanical and electrical standard. Okay, good. All right. RAID, page 761. So yeah, it's all about the capacity, speed, reliability, and cost. Those are the key factors here. So there's different RAID levels. Okay, so far so good. So RAID 0 is striping. It has nothing to do with reliability whatsoever. It's all about speed, where I bolt two drives together and I send half of the stuff to one drive and half to the other so I can speed things up. RAID 1 is mirror, where it doesn't matter about speed, it's about redundancy. So if one of the drives died, I essentially lost nothing. Drive 5 is called distributed parity. Don't worry about what that word means. Basically, it means I can survive a one-disk failure. RAID 6 is just a bigger version of that says I can survive a two-disk failure without losing anything. RAID 10 is a combination of RAID 1 and RAID 0, it takes a minimum of 4 drives to make that work. But, I'm bolting 2 of them together to be fast, and then 2 of them together this way to be redundant. So if we were asking about the capacity, so a capacity of one of these disks is, RAID 0 would be add the 2 disks together, just the sum of the disks. RAID 1 would be half of the disks. RAID 5 would be sum of the disks minus 1 of the disks. So if you had a RAID 5 with 10 drives, it would be 9 times the size of the drive. RAID 6 had 10 drives, it would be 8 times the size of the disk. Okay? And then RAID 10 is half the disk, but it's such a strange minimum of 4, so okay. All right, so again, it's about reliability and disk failure. So let's talk about RAID 0. Super fast. If you had some need for some absolutely super fast stuff, go for RAID 0. But you have to understand the risk. The risk is if one of those drives dies, you lose everything. So if you're going to do RAID 0, you dang well better have some good, very, very good backup strategy. Okay, just saying. Okay, they talk about hardware RAID versus software RAID. This used to be a big battle. I don't think a battle is still much going on now. The bottom line is that hardware RAID was offloading the CPU to do this parity check before it got written to the drives. Now that the host bus adapter stuff is so good and the CPUs are so fast that software RAID works just as well for most people. I have seen scenarios. The only place I've ever seen anyone go, well, I'm going to use hardware RAID, is when they're like at, okay, not a very good example, but at home. Okay, let's say my motherboard has 6 SATA ports on it, but I have 10 drives. I go, well, okay, I'm going to go to hardware RAID. I'm going to go buy me a card that allows me to plug in, more drives, physically. That'd be a good use case for hardware. So in a server environment where you have SAS, most likely the motherboard is not going to have 20 SAS ports on it. Most likely it's going to be a card. Most likely. Okay. So the difference between a volume and a file system on page 763. So a volume is a logical disk. So for example, let's have a RAID 1. Okay, a RAID 1 has 2 physical disks, but it shows up in just one drive letter. Drive letter A or B or C, right? So logically, it's just one thing. So a logical volume is after the RAID has done its magic, how does it represent itself? The file system, so you have some choices. In the Windows world, there's FAT32. That basically is not used for much these days, but because it was so small, it would work on a floppy disk, but only a tiny style hard drive. So now exFAT is almost exclusively used now for the USB-based flash drives. NTFS, that's the one that most people use because it has lots of scalability. The new one, Rufus, the resilient file system, it's supposed to be the spiritual successor to NTFS. It's not quite there yet, but they're working on it. And then in the Unix-based world, you have a bunch of different choices. You have EX2 and EX3 and all these other crazy things. I use one called ZFS as an example. And these have what's called journaling, which is kind of sort of what Rufus does. Basically what it means is I'm getting ready to write a file, and so I put a little check mark saying, hey, I'm getting ready to write this, and so I'm writing the file. So if something catastrophic happened and the machine lost power, boom, the machine would come up and say, well, I see you were in the middle of writing this file, but I don't see where you've finished writing it, so I know what to do. I know how to go back and recover what you've done so far. That's what journaling does. Without journaling, the machine would go, I got no idea what the heck's going on. I have no choice but to start at the very beginning and look at every single file in the entire system and see if anything is amiss. Yeah, remember check disk? Okay, Rufus basically means check disk is not required, or an abbreviated version of check disk. Directly attached. So directly attached DAS, directly attached storage, basically means that there's a cable plugged directly into the motherboard, and it's typically, although this is not really what directly attached means, it's often the case that it's physically inside the enclosure, inside the case. Okay. So a traditional hard drive or RAID, as long as it's in the cabinet, it's still considered direct attach. Network attached storage, okay, NAS. So it's a physical box. I showed you one before. So this is a network appliance. It has a CPU, it has memory, it has an operating system. Although when you take this thing out of the box and plug it into the wall, all you do is plug in the power cord and the network card. That's it. There's no place to plug in a keyboard or a mouse or video. Although it is a full computer running Linux, in my case. It uses server message block, SMB, as a network protocol. Now, network protocol, let me explain. My Linux-based NAS box uses as a physical file system, a system called ZFS, okay? But when it exposes it to the network, it looks as if it's SMB, okay? By the way, in the Linux world, they call this Samba. Kind of a cool pronunciation of SMB. So, if you recall the story, Microsoft temporarily decided we're going to change the name of this to the Common Internet File System, and the standards people went, no, sorry, we're not doing that. So the underlying physical file system on a NAS box is not relevant because it exposes itself as a Samba share. We've done that. We've done Samba shares, right? Okay. All right. So NAS boxes are file-based. Remember that discussion about being file-based, which means if I'm reading and writing to a file, I have to read and write the entire thing. I cannot say, oh, wait, give me just this one piece of the file. It doesn't work that way. You either get the whole file or nothing. Now, that's good for most things, but you have huge files. And the thing that comes together with huge files is like a database file, which could be like, terabyte, or most likely a virtual machine file. These hard drives, right? These virtual hard drives, they're massive. 64 gig is what we set our machine up for. That's one 64 gig drive. And so when it comes to write to that thing, I do not want to write all of that all at once. I want to be able to just scoot over and write to this one little piece. So NAS makes a horrible use case for storing VM files. The contrast to that is SAN, so storage area network. So storage area networks are a separate box, but they're connected via some sort of a cable, okay, to the server. It could be a fiber channel, a 40 gigabit, fiber channel. Most likely not these days. Now it's probably going to be an iSCSI or fiber channel over Ethernet, most likely. It uses normal RJ45 connectors. Plug the thing in. They typically are like, say, still have a RAID 5 behind the scenes, but they do not expose themselves directly to the network at all. Only through that cable, and that cable is hooked up to one machine or maybe two machines. That's one of the cool things about SAN is I can have two servers connected to one storage box. This one can be talking over here. This one can be talking over. They can even be sharing the same file system. It's perfectly okay. It makes for some cool redundancy. I can divvy up the space between the two, or I could have them share the space. So if one of the servers died, you're still up and running. Typically, it's going to be NTFS formatted behind the scenes because it just exposes itself to the server as this thing, and then you go in and you do just like we did when we added a disk. We went in and we told it, okay, I want to build a new simple volume. It did the partitioning, it did the formatting. That's exactly what this thing would do. It exposes itself. Now, if you want to turn it right around and put a share on that so other people can see it, that's fine. But the other people on the network can't directly get to the sandbox. They can only get to it as if you mounted it and shared it. Okay, we're coming up on the 15-minute mark. You guys know how this works.